Ever wondered how data is transferred over the internet? In this vast digital universe, we're constantly sending and receiving information, be it emails, streaming videos, or just browsing the web. But have you ever stopped to think about how this all works? How does a string of text transform into an email in your inbox or a video on your screen? Well, it all starts with the fundamental concept of data transfer. This is the process that allows digital information to move from one place to another over the internet. Just like sending a letter through the mail, data is packaged into small units known as packets, which are then sent off to their destination. But, unlike a letter, these packets don't travel alone. They're part of a vast, complex network that spans the entire globe. This network is made up of millions of computers, also known as servers and clients. Servers are like the post offices of the internet. They're the ones responsible for storing all the data that's sent and received. When you send an email, for example, it's first sent to a server, which then forwards it to its final destination. Clients, on the other hand, are the recipients of this data. They're the computers, smartphones, and other devices you use to access the internet. When you open your email, your device is acting as a client, receiving the data sent by the server. This process happens billions of times a day, with data zipping back and forth between servers and clients at nearly the speed of light. It's a delicate dance, one that requires precision and coordination to ensure that every packet of data ends up where it's supposed to. But how does a server know where to send specific data, you might ask? Well, that's where things get interesting. The answer lies in something called ports. So what exactly are these ports in networking, you may ask? Well, let's dive right in. Ports, in the context of networking, are like the doors or windows of a house. They allow specific types of data to enter or exit. But here's the twist. These aren't physical ports like the USB port on your laptop. No, they are virtual, existing only in the digital realm of your device. Let's imagine it in a simpler way. Think of your device as a gigantic office building with thousands of rooms. Each room or port is designated for a specific type of task. When data packets, let's say they're the office workers, arrive, they don't just wander aimlessly. They need to know exactly which room to go to do their job effectively. That's where ports come into play. In a more technical sense, ports are essentially endpoints in the realm of data communication. They are identified by their port numbers, which are associated with specific processes or services. For instance, if you're sending an email, it doesn't go to the same port as the one handling your web browsing. The email might go to port 25, which is traditionally used for sending mail, while your web browsing might be handled by port 80, the standard port for web traffic. This method of using different ports for different types of data is what makes digital communication smooth and efficient. Without ports, your device would be like a city with no street names or house numbers. Can you imagine the chaos? Moreover, it's important to note that there are more than 65,000 ports available for use in a typical network. That's right, over 65,000 doors leading to different rooms in our digital office building. So now we know what ports are, but how do they work? Well, that's a story for our next scene. Stay tuned to find out. How do these virtual ports manage to route data so efficiently? Well, let's dive right in. Ports, in the realm of networking, function as communication endpoints. They are essentially a part of the address that a server uses to ensure data is sent to the correct place. Picture a bustling mailroom where packets of data are the letters needing to be sorted and delivered. Now, two protocols are usually at play here, TCP and UDP, or Transmission Control Protocol and User Datagram Protocol. Respectively, TCP is like a meticulous mail sorter, ensuring each piece of mail is delivered in the correct order and confirming receipt. On the other hand, UDP is more of a quick and dirty delivery guy, sending data off without worrying too much about whether it arrives in order or even at all. So how do these protocols use ports? Well, every TCP or UDP packet that's sent over the internet contains information about the source port and the destination port. The source port, in most cases, is a random high-numbered port that the client's computer selects to receive data. The destination port, however, is typically a standard low-numbered port on the server that corresponds to a specific service, like a web page or an email server. Here's where the magic happens. When a server receives a packet, It checks the destination port number and routes the packet to the corresponding service. If the service is set up to listen on that specific port, it will receive the data. If not, the data is disregarded. And that's not all. Multiple services can be running on a server at once, each listening on a different port. This allows multiple clients to connect to different services on the same server at the same time. Think of port numbers like extensions on a telephone line, allowing you to reach different departments in a company. Imagine it like this. The server is a large apartment building and each port is an individual apartment. So why are ports so crucial in networking, you might ask? Well, imagine a bustling city with no traffic management system in place. Chaos, right? Now apply that scenario to the world of networking. Without ports, the cyber realm would be a tangled mess of data with no clear path for information to follow. Ports hold an essential role in managing multiple connections on a single server. They act like the addresses of the internet world, determining the exact destination of each data packet. Each application or service running on a server is assigned a specific port number. This number allows the server to know which application the incoming or outgoing data is intended for. Think of it like this. A server is a massive, bustling apartment complex, and each port is an individual apartment. Just as the mailman uses apartment numbers to deliver mail to the correct resident, a server uses port numbers to direct data to the correct application. What's more, ports also help in ensuring security within a network. System administrators can close or open specific ports to control the flow of data into and out of a network. This way, they can prevent unauthorized access and protect the system from potential cyber threats. Furthermore, ports enable the simultaneous running of multiple services on a single server. For instance, a single server can host a website, an email service, and a file transfer protocol all at the same time. Each of these services would be assigned a unique port number, allowing data to be correctly routed to the appropriate service without any confusion. So you see, ports are pretty much the unsung heroes of the internet. They work behind the scenes, ensuring that data flows smoothly and securely from one point to another. Without them, the internet, as we know it, would simply cease to function. You can think of ports like the traffic cops of the internet, directing data where it needs to go. And just like traffic cops, they ensure that everything runs smoothly, efficiently, and most importantly, securely. Let's recap what we've learned about ports in networking. We kicked things off by understanding the basic premise of data transfer. We learned that data doesn't just magically appear on our screens. It travels through complex networks, guided by various protocols and systems, and yes, you guessed it, ports. We then zoomed in on the concept of ports. We discovered that ports are essentially virtual docks that facilitate the exchange of data between devices. They're like the bustling harbor in a city of data, where packets of information dock, unload, and reload for their next voyage. From there, we delved into the mechanics of how ports work. We found out that each port has a unique number, which is like its address in the digital world. This number helps to correctly route data to where it needs to go. We also learned that there are over 65,000 ports available for TCP and UDP each, a testament to the intricate web of communication that undergirds our digital world. We also touched on the importance of ports in networking. We realized that without ports, data transfer would be like a ship lost at sea. Ports are the lighthouses that guide data packets safely to their destinations, ensuring that your email reaches your colleague or that the latest viral video lands on your screen. But it's not just about guiding data. Ports also provide a layer of security and networking. They can be opened or closed as needed, acting as gatekeepers to protect a system from unwanted or potentially harmful data. So, as we wrap up, remember this: ports are the unsung heroes of the digital world. They work behind the scenes, ensuring seamless and secure data transfer. They're integral to how we communicate, work, and entertain ourselves in this digital age. So the next time you send an email or watch a video online, remember the crucial role that ports play in getting that data to its destination.